This is a video for 5.2 mole roadmap. What's happening here is we're going to take 5.1 conversions and wrap it all into one map. This should help you with 5.1 stuff and also what we're going to cover today. So essentially what you should have noticed is every conversion that you used in 5.1 was centered around moles. So we're going to do that exactly that. We're going to put moles in the middle, mass, particles, and volume. So what happens is if I give you a mass, you're able to find the volume simply by going through moles. You have to stick to the roads. You cannot go off-roading or anything like that. So essentially, the first step in any problem, if you are not given moles, the first step is to go to moles, convert to moles first. So I just want to talk about each one of these bubbles first because this brings it all together. So mass, remember its units is grams. Moles, you can just abbreviate as MOL. Volume is liters, okay? So I would draw this out and put these with it. Particles. This takes a little bit more room. You need to remember FEMA. Remember formula units. Ions. Molecules, and atoms. So if you have any of those four things, that means you're starting with particles. Or if you're trying to find one of those four things, you're going to particles. Now, the other thing that you can put in your conversion map is the actual conversions. So to go from mass to moles, what conversion did we use? So remember that 1 mole equals the molar mass. So anytime you're on this road, mass to moles or moles to mass, you're going to end up using molar mass. To go from moles to particles, meaning one of these four things, remember that it's 1 mole equals 6.02 times 10 to the 23rd. So again, anytime you're going from moles to particles or particles to moles, somewhere in your conversion chart you should have 6.02 times 10 to the 23rd. Last one, moles to volume. Again, it's 1 mole equals 22.4 liters. So these are the numbers that you should have in your conversion chart depending on where you're going. So what happens is we can start off with grams and go to liters. We go from grams to moles using the conversion molar mass, moles to liters using the conversion 22.4. Now, how do you know whether you multiply or divide by them? That is where the conversion table comes in. The conversion table is extremely important that you know when to put what unit. So let's do 2 examples. Okay, now I'm going to draw a mini map. A mini map. This helps you with any problems that you're doing. So you put moles in the middle. G, FEMA, liters. Okay, you do that for every single problem. You have a map to tell you exactly what to do. So we're going to look at the problem, figure out our starting point and ending point. So it says how many formula units are in 5.5 grams of sodium chloride. So we're starting with grams. You always go with whatever your given is. So we're starting here. It's asking for formula units. Now remember, formula units isn't directly in the map, but it is a particle. It's part of FEMA. So we're going here. So what has to happen, we have to go to moles and then moles to FEMA. You have to stay on the road. You cannot go directly from grams to FEMA. Again, moles is not mentioned in the problem, so you should know that the first step is going to be going to moles. So let's set up our problem. 5.5 grams. Now we hit a problem. We hit a issue. Sodium chloride is not written in formula form. It's written in name form. You need to figure out that formula for sodium chloride. This is where students get it wrong because they forget Unit 4 stuff. So we need to write out the formula for that. Sodium is Na. And it's a metal, so that means we're doing ionic compounds. We're writing an ionic compound. Chlorine is Cl. And then their charges. It's ionic, so we're going to do their charges. Sodium is 1, chlorine is 1. Cross charges. Do not forget to cross charges. That is the number 1 mistake. In this case, they're both 1, so we don't need to worry about that. So it's NaCl. Now, if they were not 1s and you forgot to cross charges, you would get the wrong answer in this problem. Okay? So we started off with 5.5 grams of NaCl. Then it's just a pattern. If you follow the pattern, you will not get lost. I promise you. You just have to follow the pattern. So we have grams at the beginning. Grams here. What's going to happen is we're going to put grams down at the bottom. Okay, whatever's on top goes to the bottom. whatever goes on top is what you're trying to get to. And in that first step, whatever you're trying to get to in the map, that is what goes on top. Okay? Now, figure out the units, the numbers come. Moles is always 1. Moles is always 1. Grams. Okay, this goes back to the map that we were dealing with. Okay, when dealing with grams, we have to find molar mass. So right here, anytime you have grams, you have to find the molar mass of it. So I'd use this little space for that. So Na, we look at the periodic table, 22.99, but you can just round that to 23.0. Cl, there's only one Na. Cl, 35.45, rounds to 35.5. Add them up, 58.5. Okay, now what happens is grams cancel, and that's what you want to happen. Grams cancel, so we no longer need it. So now we're here, we're in downtown, but we're not done yet. We got to keep on going. You know you're done once you hit your destination in the map. So we're going to keep on going. Now we have moles on top. Whatever's here goes to the bottom. We're going to put moles on the bottom. Whatever you're trying to get to in that step is what goes on top. So now we're trying to get to FEMA, and formula units is what we're trying to get to. So we're going to put formula units on top. Okay, figure out the units, the numbers will come. Moles is always 1. Formula units, remember particles. Going back to the original map here, particles is always 6.02 times 10 to the 23rd. Okay, what happens? Moles cancel. We're left with formula units, which is what we need. So you're going to plug in, multiply the top, divide by the bottom. So when you plug this in the calculator, essentially you can ignore the ones. So it's going to be 5.5 times 6.02 times 10 to the 23rd, divided by, I would go ahead and get in the habit of putting the bottom in parentheses. It doesn't matter so much with this example, but it will the next one. Plug that into the calculator, and you get something around 5.7 times 10 to the 22nd, sorry, didn't mean to put that line there, 22nd formula units of NaCl. Okay? All right, let's try one more example. Quick map, moles in the middle, grams, FEMA, liters. Quick map. There you go. Let's figure out our starting point. So what is the volume of 4.3 times 10 to the 22nd molecules of CO2? So we are starting with our given here, molecules of CO2. Molecules is a part of FEMA, so we are starting here. What is the volume? So we're going to liters. Remember, liters and volumes are the same thing. Or liters is a unit of volume. So we're going to go from FEMA to moles, moles to liters. And your map, your conversion table should look exactly like your map. So we're going to start with our given, 4.30 times 10 to the 22nd molecules. Now, when you abbreviate molecules, you need to make sure that you can tell your C from your E. Because if you abbreviate it M-O-L-E, it's going to look like moles and you're going to confuse yourself. So in abbreviating molecules, you put a C at the end. Okay, so make sure you can read your own handwriting or you're going to get confused. Okay, and then we just follow the flow. We have molecules on top. Molecules on top, they go to the bottom. Molecules of CO2. Whatever's on top goes to the bottom. Whatever you're trying to get to in that step goes on top. So remember, moles is not mentioned, so moles is what we're trying to get to first. And then the numbers follow. Moles is always 1. Molecules is a part of FEMA. With FEMA, you're going to use 6.02 times 10 to the 23rd. Okay? Molecules cancel. We're at moles. We've hit our first destination, but not our final, so we got to keep on rolling. We have moles of CO2. Moles go to the bottom. Whatever you're trying to get to in that step goes on top. In this case, we're trying to get to liters of CO2. So there you go. And then the numbers. Moles is always 1. Liters is always 22.4. Moles cancel. Liters is what we need. So to get the final answer, multiply the top, divide by the bottom. So to plug this in the calculator, 4.30 times 10 to the 22nd times 22.4 divided by parentheses 6.02 times 10 to the 23rd, close parentheses. You have to make sure that's in parentheses or your calculator is going to do it wrong. When you plug this in, you should get 1.6 times, not times, sorry, just 1.6 liters of CO2. And that's it. Now to recap, just to put it all together, okay, this is it. When going from moles to mass, use this. Moles to liters, use this conversion. Moles to particles, use this conversion. You know that it's a one-step problem if moles is mentioned, so you only have to do one part of the conversion. If moles is not mentioned, it's a two-step problem. Also, just a little bit more, if you have grams, remember you're doing molar mass. This summarizes the conversion table for you. Grams is molar mass. FEMA, 6.02 times 10 to the 23rd. Liters, 22.4. And then moles is always 1. With this map and what I just wrote in red, and if you follow the pattern, there you go.